Bivariate data consists of pairs of values, and a scatter plot is a graph of bivariate data that consists of ordered pairs on a coordinate plane. Using a scatter plot can help you see the trend or general pattern in the data. Trends can be described as positive or negative correlations. So let's see what does that mean. Here are the trends or the types of trends between two values x and y in three different situations. The first one here is a positive correlation. As x increases, y increases. So you can see here the points at x and y on the coordinate plane, they're all moving upwards or increasing. As x increases, y increases, and points are all close together. This is called positive correlation. In the second one here, you have negative correlation, where you can find that as x increases, y decreases, and this is called a negative correlation. So the trend here between the two values x and y is making a negative correlation. In the third graph here, you can see the points are scattered all around the plane, and it doesn't have a special trend. It doesn't have a positive or negative correlation, so x and y are not related in this case. Here's an example. The scatter plot displays the height and weight of New Orleans Saints football players. In the graph here, between the height and the weight of the players, determine whether the scatter plot shows a positive or a negative or no correlation. If the correlation is positive or negative, describe its meaning in the situation. So let's look together at the graph here. You can find that the points are somehow close together, and they are somehow increasing x and y together. So the scatter plot shows a positive correlation. As the height of the football players increases, weight usually increases. So this is the meaning in the context of the situation. As the height of the player increases, his weight also increases. Now let's look at lines of fit. A line of fit is used to describe the trend of the data in a scatter plot. So what does it mean? Here are the steps to make a line of fit. We first of all make a scatter plot. So we plot the points of the data. After that, we draw a line. This line, we must draw it as close as possible to all the points. So draw a line that closely follows the trend in the data. Of course, if it is positive correlation, the line is going upwards, and if it is a negative correlation, the line would be going downwards. Then we write the equation of this line according to the equations of the slope-intercept form. And then we make a prediction. We use the equation of the line of fit to make predictions about unknown data. A calculator can find the line that most closely approximates data in a scatter plot, called the best fit line. So the calculator can make this for us. Linear regression is one algorithm used to find a precise line of fit for a set of data. Calculators may also compute a number R called the correlation coefficient. And R, we are going to talk about R now. This correlation coefficient, which is R, it measures how well data are modeled by a linear equation. It will tell you if a correlation is positive or negative and how closely the equation is modeling the data. The closer the correlation coefficient is to 1 or -1, the more closely the equation models the data. So here are some examples of R, or the correlation coefficient. In the first one here, you can see there is no correlation. There is very weak correlation, and if you find R on the calculator, it will be very far away from 1. It's like 0.02, which is not close to 1 at all. In the second one here, it is moderate correlation, and the correlation coefficient R is equal to 0.72. In the last one here, it is strong correlation. As you see from the graph, the points are very close together. So this means it makes strong correlation. And if you calculate R on the calculator, you will find it is negative 0.97, which is very close to negative 1. And of course, it is negative because this is negative correlation. Let's think about this. Write the following correlation coefficients in order from weakest to strongest. So of course, the weakest one is the one which is very far away from 1 or negative 1. So we have here the farthest one is negative 0.06. After this, it is 0.3. Okay, so you don't mind about positive or negative. You just put the numbers which is close to 1 or far from 1. After that, it is 0.54, then negative 0.78, then 0.85, and negative 0.9, and at the end it is 1, which is the strongest correlation ever.
I hope this video was useful. If you like it, please press like, subscribe, and stay tuned for more videos. So, to the next video. Bye.